So I want us to start with this. Okay. So let's assume. Let me use a text here. Let's assume I have written a code, right? I've written a very nice code here, and the code says something like y is given by something like what? Let me see. Let's say something like m plus b, something like times something like c. Okay. So let's say you've written a line, some programming code. Obviously, it will never be a single line, but I'm just thinking, for simplicity's sake and for the purpose of explaining the compiler construction process, the compiler itself, compilation, I'm just going to use this single line as an example of a programming code. Okay, so we've written a code, whichever language you've used, and now we are trying to go through that entire process of compilation. Okay, so obviously the next step over here, okay, is now the lexical analysis. So this is where we are going to find lexical analysis. Okay. So lexical analysis. I think this one will take all the time. Let me just use text. Okay. So here I have lexical analysis. Okay. So what did you say lexical analysis does? Okay. So this one is the work of the scanner. And what was the scanner doing? The scanner is going to just go through our line of code, and then it's going to split it into tokens, right? So into strings of tokens, which then are going to be forwarded to the syntax analyzer, which is then going to create the pacer, right? The pacer tree, okay? The pacer tree. That's the reason why the syntax analyzer is also known as the pacer, okay? So if you find such in other literature out there, apply the same thing. Then after that, you're going to go into the semantic analyzer to see whether it makes meaning, intermediate code, blah, 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 all the way to the end, okay? So here, after this, okay, our lexical analyzer, the one which is being done by the scanner, is going to transform this, okay, into the different tokens that are there, right? You remember what you are saying, the token type and maybe a word. So for instance, in this case, it may identify as an identifier, an operator, okay, and then an identifier here, and then maybe plus, okay, another identifier, sorry for that, another identifier multiplied by another identifier. Sorry, and then finally, a semicolon. Okay? Now, what the lexical analyzer does, on top of maybe breaking this line of code into the different tokens, what it also does is it eliminates the white spaces. Okay, the white spaces. You're going to see that in detail as we are looking for lexical analysis later. But it also eliminates the white spaces as well as the comments. Okay? I know in your lines of code, some cases you may put some comments, right? So you may do something like that and maybe say something like code, right? You may explain what the code does. Okay? So with that, okay, it will eliminate this and also the white spaces. So what you'll have is only the strings of token, okay? Which tells you, okay, you can actually write your entire code in one straight line, right? All you'll have to do is that make sure, okay, the necessary rules are followed, right? The syntax rules are followed. You can actually do this, although it's not efficient even for you as a human being when you're trying to read through the code. Now, a question for you, and I know maybe you're wondering this. So how is this lexical analyzer able to take whatever line of code you've given it and in a way categorize them into these different parts? For example, an identifier, an operator, another operator. So what does it use to get that? Okay, are these things predefined? Are they written statically that whenever you find this, you take this? Okay? I don't know whether anyone has an idea. Anyone? So how do you think it's able to turn this line of code into these different elements that we have here, the different types of software? Okay? Good. I see someone has sent a private message here saying patterns. Yes. Okay? So that is one that we should have written to it, but I agree with that, right? So patterns, yes. So what you'll have is you'll find that your lexical analyzer in its vast database will have these patterns in mind. So for instance, if you say, if I look at something and I find it's a letter, okay, and then within maybe inside it, okay, I'm just thinking it's a series of letters, right, a number of letters, and within inside it there's a letter maybe, and maybe something like that, plus a digit, something like that. And then there are so many, which means they are iterated, right? So if I see something like that, maybe I'll assume, or I'll say, let me not assume, I'll say this is an identifier. Okay, so you use certain patterns, okay, to be able to come up with the different types of tokens that we have. Okay? Regular expressions, which is something that we are going to cover a lot today. Okay, so what is a regular expression? Okay? That is what we'll be asking ourselves today. Okay? Because using those regular expressions, okay, which are patterns that describe a certain language. Okay, so actually you'll find that a regular expression will describe a certain language. So for instance, if we have a language like English, you'll find a regular expression, maybe something like a regular expression that describe maybe language or something like that, right? So that means that those are regular expressions describing that. So inside there, you'll find that there are a number of maybe something like symbols that come up with a certain language. Okay, so something like that. Right? So using that, these patterns, okay, which are known by the lexical analyzer, in this case the scanner, we are going to take our line of code here and transform it into this. Okay, I hope that is okay up to date. After that, we are then going. Okay, let me have it here. I hope you can hear me. I see people are a bit silent. Just let me know you can hear. The follow just say something, makes sense, it's good. Okay, so syntax analyzer there. So what will the syntax analyzer do? What will the syntax analyzer do? The syntax analyzer, right, will break down these, right, to give us a pastry, right? So in this case, it should design a pastry using the rules of the context-free grammar, right? There are a series of rules that are there that will highlight different things. So for instance, the most common rules that I can mention are like the four, right? I can start with, for example, the one that talks about the start symbol. So maybe it will say that in these rules, for this context-free grammar that we have, in this case, I'm just giving an example, it will say that a start symbol, right, will be made up of maybe something like an identifier. Okay? That identifier will then be equated to an expression. Okay? Then we'll have an expression. An expression in this case will be given by, right, maybe another expression. Okay? For instance, plus maybe a term. Okay, a term, or even another term as well. Okay? Then you'll have something else, and we'll go deeper and say maybe a term now. Okay, you can see that we are breaking down, like we are moving, we say something new and then we describe it, right? It's like we are going down. Okay? So a term, on the other hand, will then be made up of another term. Okay, will be made up of a term. Okay, in this case, maybe something by multiplying by a factor. Okay, something by a factor. And then finally, there may also be another factor. Let me just go there. And then finally, a factor will be nothing but an identifier. Okay? So using these rules over here, we can break down this statement that we have here. Identifier equals to identifier plus that all the way down. Okay? So we can start by saying that we have our start symbol, which is S. Okay, and then this one can be broken down into an identifier, right? And okay, and this identifier can be equated into an expression. Okay? Then this expression will then be broken down further into another expression, okay, and a term. Okay, that way. Then this term can be broken down again into another term, right, and a factor. Okay. Then now finally, all these can all actually even lead to a factor here. You can also break down this one further into a factor, and as well as this one, you can also break it down to a factor because factor seems to be the final thing at the end. These rules that we have, this set of rules I have here. So then the factors, all of them now lead up to an identifier and an identifier. Okay. So something like that. So what the syntax analyzer is trying to match, is trying to match these rules, the rules that are given, okay, to see whether your code that you've written here, my line of code, does meet these rules over here. If it does, then your line of code is okay and it's allowed to pass. If it's not, it's taken as illegal and it's not allowed. Okay? So then after that, we then move into what we are calling semantic analyzer. Okay? Semantic analyzer. And what does the semantic analyzer do? I'm not going to write it full. Okay? Semantic analyzer, right? Semantic analyzer. So in this case, the semantic analyzer will see whether whatever you have in this makes sense. Is there a meaning to it? For instance, if you try to see whether the left-hand side here, right, makes sense with whatever is on the right-hand side. So it's just trying to see whether it makes meaning. Okay? If it doesn't, then again, you're told there are errors there. Right? So after the semantic analyzer, I don't have so much to say here because we may need some additional concepts to understand this. Okay, we'll describe them further when we get them. Right? So after this, that's where now we go to what we are calling before. Let me just take it up here. it's what we go to what we are calling, okay, the ICG, so the intermediate code generator. Now, I remember when I was mentioning this, right, I started by saying that the intermediate code generator may work using what we call the three address code, the three-line address code, right? So what that means is, no matter the size of your code, right, the ICG will break it down into just three addresses, right? It will break down everything into just three addresses. So for instance, if you say something like T1, okay, so maybe this one of the addresses, if you say this T1 will hold, right, these first two, these multiplications. So it will hold something like B multiplied by C. Okay? And then if you have another one, maybe T2, right? And this one will hold now the second bit, which is now M, right, plus whatever is found to be the result of. And then finally, Y, which is the final output here, will have now the entire result of this too. So what it is doing is, right, okay, just trying to reduce whatever you have here, all these lines of code, okay, into three addresses. Okay. Now you may find even they are less than three. Okay, so the maximum should just be three. That's the reason why it's called the three address code, right? I'm told my network is a bit intermittent. Just a second, then I'll proceed. Good. I hope you can hear me. Okay. So after breaking down into these three lines of address, three code address, which is a very common structure that is used, we are going to go into the code optimizer. Okay, so we're going to go into the code optimizer. Now the code optimizer will try and find a way of simplifying all this, right? So in some cases you may not need all these three. Okay, some of them are a bit redundant. For instance, the code optimizer for this example that I have here could reduce this into just have two addresses. So that we can say now we can just have T1, which is going to have B multiplied by C, right? And also we also have T2, okay, which is going to be given by M plus T1. So in this case, what it is saying is, okay, there is no need to have this final. It's a bit redundant, right? There is no need. So the way it is this way, it just describes the entire code. So there is no need to go further into then again having another address that holds something different. Okay? Then after that, now we have our optimized code. We are just going to go into the target code generation. Now here we are trying to create a code that resembles what the assembly will understand. So TCG, let me call it that, the target code generator. Okay? Now here you will find that now the code will be defined in such a way that it aligns to assembly language. So for instance, you'll have descriptions of registers. Okay, this is something that we'll look at later on. So for instance, we may say that M is going to be stored in register 0. Okay, and then we may say B is then stored in register 1. Right, and then C finally is stored in register 2. So using this, you can actually use assembly language, okay, which has a set of rules as well. So it's very simple language actually. You'll see. So in this case, maybe we'll say multiply. So in this case, the keyword is usually MUL, mul. Okay? MUL. Let me just write that later. MUL. Okay? R1, because R1 holds B, right? And then you're multiplying it with C, which is R2. So this is what how the assembly language look. And then next, here is usually a comma. And then next, we'll say we add. I know you can see where I'm headed. We add. What are we adding in this case? We are adding R0 into what? Into R2. Okay? So the assumption is after you multiply, your result was stored in R2 for the first one, right? After you multiply the R1 and R2, the result was stored in R2. In this case, we add R0 with R2. Then finally, you will say that we want to move, okay, our results, okay, which are now found in R2. Okay, the second register is the one that is holding the final result, R2. Okay, we are going to move whatever is in R2 into Y. Okay? So then maybe afterward we can also describe what Y is, where it's stored. Right? So this now is an example of a generated code, the target code that is generated, which is now going to be fed into the assembler, which then will carry on the process. Okay? Some questions? Yes, I see a question here. So is this pastry example arbitrarily generated? Yes, the one that I have. Yes. So So I used it using these tools that I have here. Am I going to go deeper into page 3? We'll see. I don't know that I've answered your question, Brian. If you haven't, you can just say so there. Also, something that I need to mention that is very important, right? I don't know that you can see that from here, actually before the intermediate code generation, back, okay? That is what we are calling the front end. This is what we are calling the front end. Now, well, theoretically, we may have all these steps, okay? The one that I defined. I remember when I talked about the compiler, I then expanded the compiler to have different phases, right? So theoretically, there may be that many, but practically, when we are implementing compilers, we actually only implement 2 items. Right? We only implement the front end and the back end. And to be even more specific, right, the functions of the front end are actually often performed by the syntax analyzer, what we call the pacer. So the pacer, when you design the pacer, will often have all these steps: lexical analysis. You also have the semantic analysis. Also, something that I need to mention that I think brought a bit of contention last time before another discussion got into the way, right, is this question that came up: do we need multiple front ends or do we need multiple back ends? Now, I had hoped that during that time that I left it open, because I never answered which was it, right? I was hoping someone would be curious and just do research. Now, something that I think will help us is this: the front end never changes. The front end never changes. Okay? Actually, we are building a compiler, okay? And I'm going to show you some of the tools that you can use. You can take any compiler out there, and you'll just copy paste the front end. The front end will always be the same. What changes is the back end. The back end will change depending on the platform you're using. Okay? So I think it was Isaac who was saying, I think we should have only one front end and then have multiple back ends to cover the different platforms that we have. So I think that one has helped you there. So yes, so that is a better way of looking at it. Something also here that I know someone is going to ask: so what happens to the different languages? Again, that's one I'm going to leave now unexplored. So I've said the front end does not change. Okay? So do you think this front end is consistent regardless of the language you're using, the high-level language that you're using? C++, C, Java. Is it the same for all of them, or does it change? And if it changes, what happens there? Okay? So I'm leaving these questions open so that at least you can find something to just write for me and then send me via email. Okay? And then when you send that, at least I'll give you some points. Okay? So let's also challenge ourselves there. Okay? Actually, if these challenges are even if people participate in so many of these challenges, I don't see a need for me to give an assignment, right? I can just look at them and just give the total marks to people. So we have. So just go and look at that and then let me know. So maybe you may be thinking, I want to try some of these things. So there are tools out there that you can actually use to implement some of these stages. So I challenge you to go and check on this tool for the lexical analyzer known as Lex. If I'm not wrong, it's either Linux based. Yeah. I think it's Linux based. Lex. Okay. If you want to develop a syntax analyzer, there is YACC. I remember I had mentioned this in the course outline. It means yet another compiler, right? So you can use that to implement this specifically. Also, if you want to implement maybe the front end in general, okay, and you don't want maybe to just develop a syntax analyzer which covers everything, you can also look for a tool called Lance. It's also a very good one. Okay? So I've mentioned 3 tools: Lance, Lex, and YACC. So when I say I've ended my theory for this class, I want everyone to just know these words and just go and look at them. If possible, if you can download them and use them, I have no problem. And then we can continue. Yes, a question. Yes, Papa. I don't know if that's your name. I'll be curious to hear.
Yes, it is.
Oh, okay. Go ahead.
Okay, the question is, on this stage we have the ICG where we're breaking down the addresses.
Yes.
And then we have 3, then we introduce the code optimizer. Yes. That breaks them down further, 2 of them. Yes. In a case that it's already optimized, is there a fact that we can leave out the code optimizer? Let's say, for example, it's already 2 or 1, which is, let's say, probably...
so there's no need to break it down even further.
Yes. So the code optimizer isn't necessary in that case.
Yes. I hear what you're saying, but we cannot, in that case, just leave out the code optimizer. But I get, so in such a context, yes, I think your work will be even easier because the code optimizer now will just repeat whatever is here to bring it here. Also remember, right, that this part here talks about the front end, and we said that one is consistent, it's the same all through. However, down here, okay, it's dependent on the platform. So even though you may want to get rid of it in quotes, right, you may not be able to do that because it's a question of the back end that you're using in terms of the platform you use it. So even though the code may be optimized, yeah, so let's say even it's one line, right? So after you are done with everything, the ICG just developed one thing. Y is equals to T2. Let's assume everything else is not there, right? It's just this. Okay. So even though it's this way, when it comes here, the code optimizer will have still to come up with its own Y is equals to T2, so that it can cover its basis for the platform that you're using. Because this is what is going to prepare it, right, to come up with these designations for the registers, all that, so that you can do that kind of like a manual work for the assembly language. I hope that answers your question, but maybe I hope we can meet an example somewhere where we can see whether it's going to work. Yes, I saw you activated the mic.
Yes, it does. Then also a second question is ICG like determined, like it should have like, let's say, a number of addresses. Let's say, for example, this one had 3. Is it like,
I don't know whether it's me. Just repeat kindly.
oh sorry, is the ICG like determined to the number of addresses it can break down? Like, for example, this one has broken it down to 3 of them. And it have like, is it like it's basic 3 or some can have 4, 5, 6?
No. So the most common one in ICG, this is a good question. I like your question. Yes. So yes, for everyone, that's a very good question that has been asked there. Okay? So the ICG, let me see. Allow me to show you something. Oh, I like this question. Let me see. Give me a second. Let me stop the sharing. There's something I need to show you. So there's a picture I had uploaded somewhere here. And let me see if I can find it. Good, here it is. Let me share this. So look at this. Look at this. Okay? So if you remember here, we talked about intermediate code generation, right? So it results, right, similar to what, for instance, the code generator will produce 3 address codes. So this is a format that is used, and it's an example. It's one of those examples. It's very common because it's in a way like pre-optimizes the code. Okay? So the example that I gave now on the whiteboard here now, right? This one is following that 3 address code format. Okay? So that means you can have a maximum of 3 addresses. So the ICG will produce 3 addresses, either 3 or less than 3. Are there others? A very good question. Yes, they are. Okay. Can I leave that one for us to explore, and then if you find a challenge, come back. But I think for this course, I'm just going to stick. I may stick with only 3 address code. But then are there others? Yes, there are. Another one. Ask another one. Another good question. I would like to hear another good question. Let me see the chat whether there is another question, because I think I have minimized my chats. Okay, so I see. Okay. Isaac agrees with whatever I was saying. Yes, that is what I was thinking. Someone here asks, how do you make your own programming language? Huh? Okay. How does one come up with a compiler like VS Code? Okay. We are building to that. Cosmos, okay, we are building onto that, right? So these are the basic steps that we are starting with, right? So far, we've learned that there are several stages that are involved, okay, actually. But then practically, I've said, you'll find that in practice, right, you'll only implement 2 parts, the front end and the back end. Okay, actually for the front end, okay, if you are able to just implement a pacer using this tool that I'm talking about, YCC, yet another compiler, right? You've already covered the front end. So it's just a matter of now designing the back end. Okay. This one I said is a bit complex. Why? Because it doesn't follow any predefined rules, as in there is no formula that you can use. For these ones, you can see that there is a sense of formula, even the way I'm defining the rules, right? You can see that things are following certain rules, but this one can be arbitrary in nature, so it's a bit complex, but then we'll get it. Okay? Let's give ourselves time. How would you come up with your programming language? I'm going to leave that on the floor as we proceed. As I give you a breather, 2-3 minutes, just digest what I've said, then I can start with the notes. Okay, but then I like the 2 questions asked by Jaden and Cosmos. Okay, just be thinking about them as we proceed over here. Let me just fetch my notes. I hope this explanation makes things a bit better. because I know before it was a bit theoretical, but I feel the way I'm going is it's systematic, right? Slowly by slowly, you're not getting all the information all at once, so it gives you time to digest the information. Okay? Anyway, because we are recording, let me just leave here. You can just check on that later on. Let me share my notes. I also hope you are told that e-learning is up and running. So in case you need these notes, you need the recordings, you can always go there and you'll find them. Okay. I've just realized that for the lexical analysis reason, the notes I haven't completed all the notes, right? There are things that I'm still compiling. So where you find their gaps, don't worry. I'll be able to give a final version of the notes later on. But then after this class, I'll be able to upload this one. At least you have something to revise together with it. What is it called? Together with the recording. Get. So I hope that is okay. So lecture number two, we want to talk about lexical analysis. Okay, and I would like to hear from one or two of you, even if it's via chat or via the mic, what you've understood by this so far. Just say it in your own words. The reason I say that is you may find that how you've understood it may be better, right? It may be better for someone else to understand. Maybe you've understood it in another way. Maybe you even come up with a mechanical way of explaining it, right? Rather than the way I'm saying it. Maybe the way I'm explaining it is too abstract. Right? So what do you think? Okay, good. Let me just read through the comments that I see for the next few minutes before I delve into it. Amani is saying, I think the two are tied together in order to. Okay. Oh, I think Newton is talking about the question that was asked up there. Okay. I somehow agree with what you're saying. Allow me just to skip your comment for now. But then if you find you have something that you'd like to say further, don't hesitate to say so later on. Okay? Let me just read through what we need right now. Okay. So let's start with Vanessa, who said it's the tokenization of sentences. Okay, makes sense. You're breaking down the sentence into something that is well known, maybe certain patterns. That. Daniel says the breakdown of syntax to tokens. I kind of like get what you mean. Okay? Sometimes you can see what someone is trying to say, right? But maybe the way they said it will be a bit different. Because when you say breakdown of syntax into tokens, right? Someone else may understand that actually syntax is coming before the tokenization process. Because in this case, you need to think of, right? You have your line of code, right? So you're breaking that line of code into the tokens or into the different elements of a programming language. Then after that, that's how we now are going to go and check the syntax. Okay? Anyway, we'll break it down into sequence of tokens. Yes, that is taken direct from the book. I like that one, right? Break sentences into a series of tokens and remove any white spaces. What else? White spaces and comments from the source code. Yes, I agree. Actually, from what you just said, Emmanuel breaking down human readable programming language into tokens by removing white spaces and comments. Perfect. So convert high-level language to string of tokens. Yes, but now the high-level language, right, is what we have called. It's the process one, right? Pure. Actually, we call it pure. Okay, I hope you remember the previous lecture, right? Because high-level language will consist of things like what were they called? Things like the header files and all that. So we need to get rid of those, then we can break them. So I hope you remember. Okay? Convert high into tokens. That's what I've said. Breaking down entities of code into tokens. I agree with all this. I like everything, right? Sorry, I may have to skip some because I think I've read 5. Okay? But your comments are appreciated. Remember, also the way you write here on the charts or mark your attendance. That is good. Patterns. Yes, I like people who are using the word patterns because if you have to think of it, you need a way of establishing that this is this. And actually, you'll find that in a few slides over here, you'll see that you may come up with like a makeshift a lexical analyzer, what actually you can call an ad analyzer, which is not generalizing. You may actually write one in C language or C++. However, one thing you realize is you may have problems identifying, let me even say as simple as words, right? If certain words have the same kind of like a start. So for instance, you may have a keyword, which is if, okay? But then another word starts with I, for instance, Ian. I'm just giving an example. So if you design one where you don't use patterns, predefined patterns, it will be very difficult for your lexical analyzer to differentiate between this and this. I hope you see that. You are preempting that problem, right? Okay. Anyway, let's proceed. Let's start with notes here. Doesn't want to scroll. Okay, good. So lexical analysis, so the scanner, like we said, the lexical analysis is being done by the scanner, is the first component of the front end. I think we've already said that, right? Then the pacer is the second. The pacer is the one that is going out to produce the pacer tree. We say this one is a very strong defining element of the front end. So the task of the scanner is to take a program written in some programming language as a stream of characters and break it down to streams of tokens. Okay, this activity of doing that is what we are calling lexical analysis. Okay, let me give you a simple example. So I always forget that line. I always like to use that line, but I always forget it. The line that has all the letters in the alphabet. But anyway, let me say, today is a good day. I want to challenge you. Okay, I want to challenge you. So here, I want to break down this sentence into streams of tokens. So in this case, this is the English language. So we need to break it down into the building blocks of the English language, which are the letters. Okay, those letters are going to form the tokens. So I want you to tell me how many tokens are in that sentence. Take your time. Today is a good day. Today is a good day. So how many tokens do you think are there? I'll give you a minute. Remember, we are using the English language. Okay. English language. And like I said, we are using the building blocks of the English language, which are single alphabets. Single alphabets. Victor, consider your answer. Consider your answer. Okay. Good. Now, as you write that, right, just pause for a second. What am I asking for? Anybody who understood what I'm asking for? Right, whatever you think I'm asking for. What am I asking for in this case? Good. So someone has just asked a very important question. Do the spaces count? Okay. Do the spaces count? Exactly. We need to remove the white spaces. We said the white spaces have been removed, comments have been removed, but now I'm saying this is a context where we can say we are using this certain programming language, and in this case, our programming language is English, just simple English, right? And the tokens in this case will be determined by the building blocks of that language, which in this case are the alphabets. Okay. So what I'm asking for is to just break down the number of alphabets are here, the number of alphabet symbols, right? A, B, all the way to Z, right? So how many are these? So in this case, you have 1, 2, 3, 4, 5. Remember, white spaces are not there. Okay? 6, 7. So in essence, it's like you're bringing this thing together. Let me do that. Okay? You're doing that. You're doing that. Okay? So in this case, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15. Okay? However, you'll find that in other languages, I need to mention this so that I can explain why also I didn't say wrong, Victor. Okay? In some cases, you will find that certain languages, right, will define certain tokens as strings. Okay? So, for instance, there are those are they keywords? The one that talks about this. Tell me which language is this. There's somewhere when you are trying to call on something, you use this. I think it's a percentage, then ID. Okay? So instead of breaking this one into 3 tokens, you'll have this as 1 token. Okay? You may find that one somewhere. We'll not go deeper into this, but it's good to mention that. Okay? So anyway, oh no, I didn't want to delete that. What has happened? Okay. So in essence, right, your lexical analysis is just doing this. Okay, it's just doing that, right? It's just doing that. Also, the reason why I said us to discard the white spaces for us is because, right, I wanted us to see how the lexical analyzer, because the lexical analyzer assumes the white spaces, it skips over them and does not happen there. What else? It also doesn't see the comments. Okay? So in this case, I just wanted to see the unique tokens based on that language that we have. Okay? So maybe we are looking at the regular expressions now, which are those. Okay? So that is what it does. So a token, however, okay, contains more than just word extracted from the input. So a lexical analyzer partitions inputs strings into substrings called words and classifies them according to their role. Okay, according to their role. Let me just edit this. Let me just put the next slide. I can see my chat is popping. Just allow me to finalize on my thoughts and then we'll continue. Okay, so now this one on the other hand, okay, the one that I have here, different way to look at it, right, from the English language, right? You can break it down into what I said. You remember when I was talking about breaking down that, right? I said you're breaking it down, right? Breaking it down, right, based on the building blocks of the alphabet, right? A, B, C, and all that. But also another way that you can break it down, the process of tokenization is also you can break them down based on their words. Okay, so maybe you can break them down in terms of maybe this is a noun, this is a verb, this is an object, something like that. Okay? So that's a different way to look at it. Right? I'm just giving you a different perspective on it. Right? So a token, okay, that synthesizes now the sentence of a language. So now in this case, it's not about the alphabet, right? It's about the languages. So we can have an example like this one. He wrote the program. Right? So you can break down this one now into the words. Now I'm talking about the words, not about just the characters, like I said before. So in this case also as well, okay, the white spaces will be eliminated, right? And you'll just have he wrote the program. So those are the important elements in this case. Okay. So again, like I repeat, the blank spaces between words have been ignored again. Okay, they have been ignored. So these words now you can classify them based on their roles, like I said before, based on their roles. So for instance, we have a subject, we have a verb, we have an object, etc., etc., etc. These are their roles. I hope that is okay. That is okay. Now let me bring it home now into a programming language case, okay? And then I'll go and check the chart and see what it's about. So similarly, the sentence in a programming language like C, which is this, if B that 0, okay, bracket that, we can also break it down, right, into the different tokens. I hope I gave you the example. Okay, yes. Okay. So in this case, the words will be if, right? There also be, let me see whether I can copy paste that. Whatever I have there. Well, at least it's not lost. Okay, so we have that. So in this case, okay, comes there. Go away, yes. That. So in this case, right, we have if, okay, which is there. Then the next one we have is this parenthesis. So you cannot forget about the brackets, or the parenthesis, the brackets, right? So the brackets are also another token. It's another element there because you cannot ignore it, right? It has a purpose. Right? So we have that. Then the next one is B. Then after that we have this operator, right? The Boolean operator. And then after that we have the Boolean operator is this one here. Then we have the 0 over there. Then we have a bracket there again. Then we have A. Then also we have equation sign there. And then we have B. So that's what we are breaking them into, right? I've just opened my chart and I see, I don't know whether it's an argument that is ongoing there about white spaces. You'll let me know what it is. I'll come there in a short while. Okay? Now, as you'll see, right? As you'll see, a programming language will define certain tokens. Okay, certain tokens will have been predefined. So I think for the person who was asking, so how do you come up with a programming language? This one is a way of looking at it, right? So you have to come up with things like identifiers, like you can see, these are examples of identifiers. You'll have to come up with keywords. I think integers will stand. Okay, integers will stand there, things like floats, and then symbols, right? Because all those are the building blocks of that. Okay. However, a question that still stands out right now that I hope all of you have in the back of your mind is, so these tokens that we are talking about, right? Tokens. Okay. We need a way for our machine to automatically generate them. We need a way when we write something like the line of code that we have here, right? We need all of them to be written in a way that there are no errors that are found, right? So if you follow the rules, you have it. Okay? And the way that we achieve this tokenization is through the patterns that I'm talking about, through the patterns I'm talking about. Okay. And here comes the challenge and the problem that I was talking about, right? Let me just cover this and then I'll go to the chart. This is the problem I was talking about. So think of a case where, right, we just want to come up with a very simple lexical analyzer. Maybe we just come up with actually something like a Lexa class. Right? And the Lexa class will just look at the word. So if you're going to write a line of code, maybe using the certain class. And then whenever you type a sentence, what this code.js will do is that it will break it down into the different tokens. Okay? So we are actually just having a handwritten code to generate the tokens. Okay? In this case, it's partitioning maybe whatever you given it as the inputs, right? From maybe from the left all the way to the right. Okay? So in some books, you'll go and see words like LL, LR. Okay? So something like left to left, left to right, something like that. Okay? something like that. So in most cases, the one that is commonly followed is the one you're moving from the left to right. What that means is that your scanner will just be moving from the left here and going all the way to the right. So it's going to be scanning, for instance, this sentence and then breaks it down into the different tokens that we have. Okay. Now, I have even that example of the line of code, even though I did not write it entirely. So this will be an example where you've just written a class called Lexa, and then you're just partitioning the different items that we have, right? So it's an incomplete code, but then I'll give you the full code later on. But one thing that you're going to find is an issue in this case is, in case you find that certain things have words that are have similar elements, right? So for instance, like I was saying, our words begins with an I, okay? To begin with an I, but then there's also a keyword that starts with an I. So for instance, like I said, Ian and if. So how will it be able to differentiate between the two? Or maybe even this, okay? These two symbols. So you have equals, but then you have the one that has double, right? I hope you still remember what is the difference between this programming language. Okay? So this is one of the challenges that you'll experience if you come up with this just a handwritten code that generates the token, right? You need a way that is a way of generating these tokens automatically without having to error. And this is where the idea of having describing tokens using patterns comes in. Okay? And that is where we are going to learn about regular expressions. Now, before I go into this element of describing tokens, let me just jump into the chat and see some of the questions that are being asked. If you have a question, you can ask, because I think up to there we just described the general case of what the lexical analyzer does. So now we want to go deeper into understanding how we can describe the tokens themselves. And this is where now we are going to shift a bit, go deeper into regular expressions and what they are. Okay, so let me see. So I think I left off where someone was asking about eliminating the spaces. Yes. Yes. You'll have to count the repeated letters, because something like good and God, right? You see, you can't assume one. The spaces and comments are not counted. Yes, the lexical analyzer eliminates the white spaces. Yes, does it also assumes commas, full stops, or only white spaces? Just white spaces. That is very important. But because you'll find, right? You'll find that something like this, right? It's part of a programming language, so you cannot ignore this. The white spaces are the one that are ignored in this case. What else is there? Also, someone is asking, through the space help derive the meaning of the sentence. Now, how best can I help explain this? So if we have a word like this is home, right? I want you to understand one thing, right? So we are trying to move from human readable language. So I understand when someone says the white spaces are helping you understand the meaning. That's us as human beings. That's us as human beings. But remember, our objective in this case is we are trying to transform this into what the computer understands. So the computer, so long as it has the critical elements of that sentence, it will be able to derive meaning. Okay? For it, the white spaces are not supposed to be there. I hope you see that, but I understand what you did, Wambua. I still like you're reverting to someone else's comment after. Probably he sent it privately. But I hope that is okay. So actually, what would be more important, actually, the punctuation. Yes, minor. Whatever you're saying is also very good. So the spaces do not change the meaning or interpretation, but punctuations are very important. Yes. So yes, I agree with you 100%. Okay? Things like commas and full stop actually hold more weight compared to spaces. But then I'm not refuting whatever one boy is saying up there, because as a human, okay, those white spaces are designed for optimization of, when you're reading the sentence, right? If I was to put this way, let me show you. Okay. Now I know this is a very short sentence, but you'll still make headway of what it means, right? But then the white spaces do help, but they only help us when we're reading. Okay? But then the meaning does not change. So punctuations are actually the one that are put in more. Okay. Okay. Wambua then goes back. Rebecca. Let me use Rebecca. Rebecca then goes further and gives an example of children slaughter. Okay. And she talks about that. I agree. So you can see that's kind of a limitation of computers. Actually, let me challenge you this, right? So there are online tools that you can use to check your grammar. I don't know whether you have, right? Things like Grammarly, something like that, right? So if you ever assignment, if you don't proofread it as a person, you as a person, and then you just use those automatic tools for them to check for your grammar, chances are it will have a lot of inconsistencies because of such limitations. Okay, you see, a computer is like breaking down these white spaces, not including them. So this is the reason why you'll find that you're always told to proofread it, you as a person. You as a person, right? Because even though our machines have automatic way of classifying these sentences, breaking them down so that they can follow the rules, they will ignore the white spaces, but then they'll take note of things like commas and full stops. So yes, I do agree with you. I think that is something actually you can even write something about. Um, when you're trying to derive the meaning, sentence changes is sentence analysis. Okay, okay. Makes sense, Junior. Just say there. Makes sense. Makes sense. Does that that is being asked in this case? Right now, you need to remember the example that I'm giving here of sentences is just I'm just trying to go from somewhere where people understand, okay, to somewhere else, right? But you need to understand that in this case, okay, a lot of the emphasis is being done on a certain programming language structure. Okay, a certain programming language structure. So you'll find even those maybe context may be understood, right? They don't necessarily apply to what us as human beings are interpreting, okay, and what we are thinking. Okay, so something. Let me see another question here. What of the machines that are programming Chinese, Russian, and others? There is no space. Okay, okay. I think that one. Sorry, I don't want to close the door on this, right? Because I feel like we may get lost with what we are trying to delve into right deeper, right? I don't want to bring the association of the human language where we are speaking, the language that we are speaking, right? Because the examples that I gave with the English language, right, I was just trying to go from a place where you understand as we go further, right, into programming languages. Right? So yeah, so the question of maybe breaking it down into languages that do not have white spaces, um, may I request you check on that? What would happen there? I've honestly not checked on that. Okay, but I do agree. For us as human beings, the spaces are very important, right? But the reason, the example that I gave of those automatic tools that we use out there for checking our grammar actually are verification, or their way of highlighting that these spaces are very important. And because they lack in machines, is the reason why if you use them automatically without proofreading your work, you'll always have inconsistency in whatever you write in there. Okay. Yes, Victor, I agree with whatever you're saying, right? I'm building up to that, okay? I just wanted to start with a simple example so that I can illustrate how the tokens are coming around, right? Because remember, I haven't gone into that idea of the programming language, right? I was just giving the general examples of using subject English language, and I was just to show what tokens can be in this case, right? What tokens can be. Yes, so actually the technical terms will be the lexemes, right? I have no problem with that. Okay? So yes, Victor, whatever you're saying, that actually is technically the correct terms. Okay? But I just wanted to start from here, and then later on as we build up, we'll get to see them. Let's hold the questions there for a minute. I'll be able to get back to them. Okay? And I want us to spend around 5 minutes, as we check on this. I want you to go and check on what a regular expression is. I want to delete this, not going away. Yes. So I want you to check what a regular expression is. And if possible, come back with an example. 5 minutes as I sip some water over here, and then we'll proceed.
He's done a lot of sense, but these players are so ready to play. We're already into game one as the first stocks are getting ready to be sealed. Yes, sir. Yes, sir. So here we go. You
Yep, I'm back. Oh, so many comments. Oh, great.
Right at
Mhm.
He's going to be able to take this one.
Let me say this. If you ever find this, I think this is a disclaimer I need to give. If you ever find there's a question maybe you asked on the chat, because I see people are very active in this class. If you find your question hasn't been answered, you can always contact me later, or you can just activate your mic. But if you feel the mic you're not comfortable there, always forward me your question via email. I always appreciate, right? Because I see there are so many comments that in some cases I may skip one or another. Right? But yes, so I can see the general idea over here. Regular expression specifies a set of string that matches it. Regex sequence of characters that defines search patterns. Yes, regular expression is a string, e.g. Yes, okay. So yes, so many comments. I think over 20, right? But I hope you get the general idea, right? Okay, you get the general idea of what everything that everyone is writing there, okay, seems to try and highlight, right? We are looking for patterns, okay? And maybe a better way to look at it is what I have on the note. Let me use what I have. Okay? So one of the best ways of describing the tokens, okay, and maybe let me be technical now, right? Actually, with regards to whatever, I think somebody mentioned, I don't know if it's Victor, someone was mentioned the technical bits about it, right? Now, if you remember when we were talking about tokens, right, we said that a token will be defined actually by a token type, okay, a token type and a word. So that's why you'll find it as something like an identifier and maybe a word. So let me just delete this, sorry.
Longest drive today. So the longest drive to you.
Okay. So one of the best ways to describe tokens, because these tokens you need a predefined way to match them with whatever you are writing in your program. Right? You need it. Right? One way to describe this, okay, is using regular languages. Regular languages. Okay? And I know you may ask yourself, what is a regular language? A regular language is a language that, in simple terms, follows certain rules. There are certain rules that are used to construct that language. So a question for you. So is the English language a regular language? Is Sheng a regular language? Okay. As you ponder that question, look at. So regular languages are the most popular ways of specifying tokens because they are based on simple and useful theories. Okay. Number two, they are easy to understand. And finally, efficient implementation exists for generating the lexical analyzer based on such languages. So before we go to describe what a regular expression is, right, we need to understand what a regular language is, because this will describe that over there. Okay, and take this example of a language. Okay, a language, okay, that has this, let's say it's a set, okay, be a set of characters. Then this set of characters can be called an alphabet. So for example, in English language, you have A all the way to Z. That is your set. So that is called an alphabet. Okay, so a language over this set, okay, will include a set of strings. So a set of strings is the way you break OD, right? Or BAD, right? So that's a language you're starting to build. Okay, and you can even have examples in the next slide. I'm told my network is a bit poor. Bear with me. Okay? Examples like this, right? The English characters, right? That's the alphabet. This is an example. The English character. The language will be English sentences. You can also have an alphabet, for example, called ASCII, right? ASCII. You remember this? These are coding scheme that is used in computers, right? So the language can be things like C++. Languages, okay, are just a set of strings, okay, which means it's a finite sequence of characters. So I'm just giving an example of using the human language, okay. Then we'll need that. Maybe you can transition it into the programming if you need to look at that. Okay. So that language, right? That language that we have, right? What the lexical analyzer does, okay, it tries to find a way to describe that language that you have. So for instance, if you have a language, maybe A, okay, you try and come up with something that can describe that language. And this is where the idea of regular expressions comes in. Okay? Because each regular expression is just a notation of a regular language. Okay? Which in this case, I keep on repeating this, the regular language is just this. Okay? So for example, the English sentences which form that. Okay? Now you'll often find notation like this, right? So when we say like if A is a regular language, okay, then we can just write LA, okay, to denote that language. Because this here is the regular expression that is describing that language. Okay? So you can also maybe see it like this. So you have a language, and then the regular expression may be something like that in brackets. Make sense? Make sense? Somebody say amen or something. You've been a bit silent. Somebody say amen. I don't feel like I'm alone. We have. Okay? Now, there are certain rules that are followed. I'm about to go into a section where I remember when I was an undergrad, I faced one of the biggest problems trying to understand. Because the rules that I was told when it comes to writing regular expression were in this notation. And I really never understood what they meant. Okay? I'm about to make our work very easy, by describing them in words. Okay? So bear with me. I'll write for you this one later on. Okay? But if you are able, have a pen and paper somewhere and write, because they'll describe 5 rules. Okay, if you look at them, these are 5. There are 5 of them, and then I'll put them in wording. Okay? So a regular expression is used to represent a certain set of strings in a language, but now we are describing them using algebraic fashion. Okay, so a bit of math, algebraic fashion. Okay, and the first rule over here, this one, maybe just think of it. Okay, so if you think of any symbol, a terminal symbol, something like A, I'm giving an example of A, right? Okay, which will include even the empty and the null. Okay, empty and the null. Okay, that is a regular expression. Okay? So think of any symbol that is contained within this set that we've talked about. So the set in this case can be describing any language that you're thinking of, right? So any terminal symbol, including the empty and the null, are regular expression. Again, like I said, I'll be able to write for you later on, and then I'll put them on e-learning. Okay? Then the second one. The union of 2 regular expressions is in fact a regular expression. This one is here. The union of a regular expression is a regular expression. Okay? I think I've already mentioned this in terms of even having an empty string. An empty string is also in there. Okay? So that is another one. So the union of two regular expression is an expression. The number 3, this one, okay? The concatenation of two regular expression is a regular expression. Okay? So what we'll put is, I think it's good if I also describe. Let me do this. So this one we can say something like I said any symbol. So something like A, B, C, blah blah blah. Some cases you may see empty being called this epsilon, or the null. The null can be represented by the phi. Okay? Then an empty, yes, I think will also goes there. Will also be there. And then when we say like two regular expression, you can say you have two regular expression R1 and R2. Okay. Then you have a union. A union, if you remember in your digital logics or Boolean algebra, is written as R1 plus R2. That's another way of looking at it. You can also denote them with that symbol there. But I think that one is better. Then the other one is concatenation, right? So if we have R1 and we have R2, right? Then the concatenation is just like multiplication, like you're putting them together. So dot R2. Okay. So that is also a regular expression. Okay. Then the other one here, let me just allow some people to come into the class. The other one here says the iteration or closure of a regular expression is a regular expression. This one here. Okay, that means if you have R, even these examples. So if I have something like A, letter A, and I say closure of it means it includes even the empty, there is nothing, empty string, then also A alone, then also 2 A's, then also 3 A's, then all the way to infinity, right? That is also a regular expression. Okay, and then a final rule that often is included here, right? That we often say is that regular expression over this set over here, of a certain language, okay, is formed by following these rules up here. So all these rules, when you combine these rules in different ways, you iterate, you recursively apply them, right? You'll form a regular expression over a certain language. And in this case, okay, I want to give us some examples here. I want us to see some examples that will help make things a bit clearer, right? A bit clearer. I don't know whether there is a question on those rules, even though I know they are not written in words, right? I know you're gathering some information there, right? So number one, I think I can just say them basically. Number one, any symbol within a certain set, right, is a regular expression, including the empty and null, right? Number two, when you have two regular expressions, their union is a regular expression as well. When you have two regular expressions, the concatenation is also a regular expression. Then any iteration of a regular expression is a regular expression. Then to form regular expressions, now the ones that we are going to be using, right, you'll just apply those rules that I've mentioned in different ways. I think it makes sense. Someone can acknowledge and say something. Okay? I want to give some, I will have to delete this. Let me delete this. Okay?
Yeah.
I want to give some sets over here. Okay? Some sets of symbols and characters, and I want us to describe them using regular expression. Okay? So I can say this. Let's describe all of them using regular expressions. Good. I think I get one here down here, and I'll start with number one. Can we describe this? So we have this set that has 0, it has 1, and it has 2. So we have that, okay? And I'm going to give hints over here, and I'm going to just guide us, and then I'll give maybe examples and questions that we can describe. So the way you read this set is this way, right? You read that this set over here, which is made up of maybe it's a language over here, right? Is made up of these 3 different symbols. Okay, and what we are saying is, okay, for this one, okay, what we are saying is it's made up. This set is made up of 0, or 1, or 2. Okay, so I don't know whether you remember somewhere where we've highlighted, right, a way that we can describe this notation and the way I've said it, 0 or 1 or 2, using a certain rule of the regular expression. If you remember, right, this seems like a union. Right? This seems like a union. So if you are to define the regular expression that defines this set over here, you can write it as this regular expression will be given by 0, right? You can just use the plus symbol. Okay. Let me give another example. Look at another set over here that I might have. Okay. So let's say we have something like, do I have an empty? Do I have an empty symbol? Yes, empty, 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 and then comma, something like a letter BC. Okay. So this is a set in a certain language. Okay. So what does this mean? This one means, okay, you can only have these two symbols. You can either have the empty string or you can have BC. Okay. So when you only have two options, I know someone may read this one as empty or BC, but because they are just two, okay, we tend to look at this as a concatenation because you are trying to restrict whatever is going to be built from this, whatever you can build from this set of strings, right? The only thing that you can build from them is only these two, either empty or BC. So in that case, when you only have two options, right, the regular expression that tends to define it will follow the rules of concatenation. So in this case, you'll just have that, and then something like dot BC. I'll go even further. Don't worry if it's a bit vague, right? I'm just giving examples so that at least I can lead up to where we are going to actually apply the regular expression itself. So let's take another AB, right? And then A, then B, and then something like BBA. What do you think this one is going to look at? How is the regular expression going to look at? These are very basic, just basic versions of regular expression. So if it was you, okay, and don't feel like your answer will be wrong. Just attempt. What do you think? How would you describe the regular expression based on the small examples that I've given here? The regular expression will be given by what? Are we still here? I'm on mute. I think we are. Okay. Now, the first thing that you need to do here is just try and read this one out loud. How would you read this? Okay. So in this one, you treat it as A, B, algebra. So that I can say these are sets. These are sets. Okay. These all these are sets. Okay. So this one, you can see it as AB, right? BB, or I see even people have even gone even further and broken it down to the actual regular expression, right? But for the sake of building, I want to build people slowly by slowly. Okay, you can also look at it as that, okay, or B, okay, or BBA. But then, if you've been able to identify the patterns that are common among them and just identify them and pull them out, then I'm okay with it. Because in this case, you can just look at this as ABB, okay, plus A plus, okay, B plus BBA, right? And then now you can just break it down, right? You can just reduce it using your algebra so that you can maybe find whatever answers people are getting there. So perfect. I think I'll have a very easy time in this class. Okay? Then let me go to number 4 and see whether people are going to get that. What if I have the other set over here and I say it consists of empty and then it's only using one symbol, which is 0. Which one do you think this one is? What regular expression can describe this? Perfect. I hope everyone is seeing that, right? So the regular expression in this case is just 0, 0, asterisk. Because this is a closure. Okay, this is a closure. This is a concatenation of 0. Are we still together? I only see John Waithaka is the one who saw that one. Okay. Maybe my network was low. Let me repeat another one. Number 5. What if I have this? I have 1, 1, 1, 1. What is that one? Which regular expression can you use to describe that one? Good. Now this is what I wanted. I wanted people to have these different answers, right? So there are some who are saying this is still a closure, and others are writing it as a plus. Okay? Now this one, something that is very important that you need to see, and I hope everyone is seeing this, right? If you look at this set over here, the empty string was included. So there is an empty string. But then for this one, the empty string is not included. I think I need some water. The empty string is not included, right? So it starts from a 1 and then proceeds. But then this one starts from an empty, then 0, that's it. Okay? So this one, we often denote it with the symbol and then a plus sign to say that the empty string is not included in that set. Now, I found this in literature, and I remember this was one contentious issue that I had with one of my lecturers back then, because there are people who will say that there is a closure, okay, without an empty string. I never understood that. And actually, to this day, I still find literature, some literature will say that. I hope you can see that these are empty. Let me just delete that. Okay. There's some people who would say that this is a closure without an empty string. I never understood that. Here's why I'm saying that. Okay. Why would you call something if it lacks something within it? As it's like saying, I have a vehicle, but it doesn't have 4 wheels, it has 2 wheels. Why don't you just call it a bicycle? Anyway, I don't know. Maybe the notation may be a bit different, but I found this in literature. So if you find that, okay, I just wanted to mention that. Don't feel confused, right? Oh, I see a hand. I like this. Yes.
It's actually a question.
Okay.
I've understood most of the concepts except on the second regular expression.
This one here.
Where, yes. Could you please explain again why the regular expression is a concatenation?
Okay, but are you okay with this?
Yes, everything else I've understood.
Anyway, before I go back here, right? I hope I don't know whether we are in the same page when you're looking at this, right? Anyway, maybe there's a unique name that is used to describe this kind of a regular expression. Okay. Based on those rules that I have over there, because we've talked about the closure, we've spoken about the concatenation, and as well we've spoken about union, right? And also the one that has an empty or symbol. So maybe go and check whether there is a unique name that can describe this, and then let me know. You never know. Okay. So here. So the reason why I'm calling this a concatenation, right? I've forgotten. I think it's Stacy who asked. Yes, Stacy, right? The reason why I'm calling it a concatenation is because only 2 items. Let me even use that vague term and generic term. Only 2 items are considered, right? Something like an empty, or maybe let me use one that doesn't have an empty. Okay. Take this one for instance. Let me have another example here, number 6. What you can come up with from this set that I have is only A, or even I can even Q, comma, something like Y, something like that, right? So what I was saying is, right, when you're coming up with the regular expression for this, right, you need to limit whatever you can come up with, as in whatever, can I say words, okay? Whatever words you can come up with from this set that we have here, you want to limit them only to Q and Y. Okay, it somehow also borrows from the human readable language, right? So I understand you may read it as Q or Y, okay? But in this description that you're talking about here, right, we often leave the word for or, right? A union, okay, when we are describing more than 2 items. So maybe like 0 or 1 or 2. But when they're just 2 items, only 2 items, right? Only 2 symbols in this case, right? You want to limit whatever you're going to come up with to QY. Why? Because in this case, maybe what you can form is just QQ, QY. What is that? Yeah, Y, and then YQ, and then finally YY. Okay, so you want to limit only them to those 2. And actually, okay, that's the reason why I'm using concatenation. I don't know that it still appears to be vague.
I've understood, but
yes.
Is it to mean that now whenever we have 2 values, we can't have an or?
Come again?
You said that we usually exclude the or for more than 2 values in a set. So is it to mean that when there are 2, we can't have or? You can't say Q or Y.
Not unless there's an empty. if there is an empty,
Okay.
because you may make that presumption, right? I don't want to presume that someone has presumed there is no null or empty. But if there are just two, yes, just use concatenation, because that will help you, right, come up with these entire words, that the words that you're going to have in this case, which are false.
Okay.
Okay.
Yeah.
Let me see. Let me go back to my rules and see whether there's something else I've missed. Are you able to see my screen? Or I need to stop and share again. Okay, I think you cannot see. Just a second. I'm using two screens, so sometimes maybe I think when I share something. What is the problem? Second. Can you see that? I think you can see the whiteboard, right? I think you can see the whiteboard. I think you can see the whiteboard. Yes, I think you can. Let me write something here. So if I was to say describe following sets using is there a hand? I've seen one and then disappear. Just a second. As I try and solve my issue with the screen, let me just give some examples here. Look at the following sets and just try and see what you can describe them, right? So describe that, number 2, something like something like I know I'm just repeating, possibly maybe similar to what I just had. But allow me as I try to solve what issue my screen. Let me see. So, for instance, I saw a hand somewhere. You can be saying something as I try and sort my issue with the. Just try and describe those ones.
Hi.
That are often used in regular expressions.
Hi.
Yes, how are you?
I'm fine. So based on Stacy's question, so what is the conclusion? Are we supposed to concatenate when we have only
I
two?
see your mic is moving, but I can't hear you now. Is it my network?
I'm not sure.
Come again. Just say something.
Okay, so based on Stacy's question,
Yes.
what is the conclusion when you have only two characters in a set?
Only 2.
Yeah.
Yes, just concatenate them.
Oh, okay. Thank you.
Oh, by the way, this is just the building, okay? So chances are you'll not find things as easy as that. But anyway, we'll build them. But yes, I think that conclusion is needed.
Okay.
Am I going to be able to write all these identity? Okay. So I have over 12 different identities of regular expressions, but I think I'm just going to mention like 2 or 3, and then the rest I'm going to attach them in the notes. Then we'll do a big example. Oh, also, I see someone is asking they're a bit tired. Okay. We can have a break. Be looking at this. As I see how I can be doing something. Yeah, sorting my issue. So look at this, and then let's have a 15 minutes break. Then we'll come back and finalize. Then we can have our lab time. Or maybe 15 minutes is a lot. What do you think? Let's have 12 minutes so that we come back at 11:01. Then we'll spend like a few minutes and then we can. Okay, 15 minutes it is. those tools that I spoke about. Okay. So yes, here there was no concatenation. All of them are going to be or, because if you concatenate, you'll have other items that you don't need. It's just a union. All of them, just put them as a union. So plus, plus, plus. So this one and this one are similar. Okay. I want to talk about identities, but then I'll post the identities that I have on regular expressions on e-learning later on. But if you have time, you can always check on some. And I want to start. What do you understand by the word identities in mathematics? What does identities mean? Expressions. That's right, RE. When I say identities, what do you think I'm talking about? Are we back? Let's acknowledge we are back first. Need a straight line. Need a straight line. Down all the way up. That's okay. Yes, good. So what do you understand by the word identities? When I say identities of regular expression? Identities. What do you understand in mathematics? When I say something, I talk about identities of certain. Okay? So we are just looking at equality relations. Okay. For instance, when we say A equals to B, we are just saying that A, whatever you get, maybe A describes certain variables and as well as B. So when I equate them, I mean they are the same. What I mean is this. So for instance, one of the common identities that you'll find is this one. I'll say, for instance, phi, right? When we say that null and a regular expression will be just a regular expression. That is one, okay? Another common one that you may find is the one that says regular expression. This is another one common. Yeah, a regular expression, then you do closure of it. And then on top of that, you also do another double closure. Right? This is just one closure. You can just see it as that. You see what I mean? This is what I mean by when I say identities. Another common identity that you'll find out there is the one that has this. So if you have one regular expression, and then you put the union of the same regular expression again, the same one, it's still just the regular expression. Another one that is common, I'm just looking for one. Okay, yes. Think of this one. Okay. You have phi, and then you concatenate the regular expression. Then you have regular expression again, concatenate it with phi. This one will still give you phi. Like looking at 0 multiplied by something plus 0 multiplied by something else. So it's just 0 that way. Okay, so phi. So these are some of the identities. They may help you to simplify some of the regular expressions that you find in the end. That's the reason why I'm saying I'm not going to go through all of them because there are several. So also another one that is common, maybe you have a regular expression P, then Q as well. You concatenate them, okay, and then you have their closure, okay. Then you concatenate P. So this one is similar to having this, right? So you remember the order. It's similar to this. You can also change the order this way. So this is another one. But the good thing is that I'll have this available for you. It's not something that you have to keep on memorizing. Okay. The other way you can prove this, but then this is not a mathematics class, so I don't think we are going to spend time just doing that. Maybe I can highlight one that I see maybe a bit. Here is also R, maybe a regular expression, another regular expression. Okay, same one, then you do this. Okay. It's also I'll have these ones there, and I know the question that will be asked. In case you examine, will this one be given? Yes, they will. Okay, we are not here to memorize these things, but then chances I will not give basic questions like those ones where you have to do this. Okay? I want us to do one question here, an application of regular expressions, and I think that one will help make things much easier for us before we can go on. Okay, so I want us to design regular expressions, okay, for the following languages that are designed using the following set. Okay? So I want us just to use a set of A or B. We'll only use those two. Okay? And the first language I want us to design, okay? I want us to design number one, okay? A language that accepts strings and exactly.
So Malnati was
That's
at
number one,
15
and then
under.
number
One of the
two, I
overnight
want us
leaders,
to
Matt
want
Sergio, getting off to a
language
fast start. Getting off to a fast start with the birdie in the first, and the question mark was going to be how well.
Strings of length at least 2. Number 3, I want us to design a language sets strings of length at most 2. So here we have a set. Oh no. Okay. I hope you're able to see. I wanted to stretch this, but as soon as you unselect it, it just disappears anyway. So I want us to design languages, okay? Design regular expressions that will describe the languages that do this, okay? Using only this set over here, that is of A or B, right? So the first one, what do you understand by the first one? The first language that you want to design here, okay? Because the regular expressions describe languages, okay? So if you want to design a language, you can just develop the regular expression, and then that regular expression will just describe the entire language, right? So in this case, when I say I want to design a language that accepts strings of length exactly 2, what does that mean, right? So using A and B, right? A and B, right? I want only, okay, only strings that are of length 2. So the first language 1, means you can only have something like AA, right? Because using A and B, using these two letters, you can come up with so many languages, right? You can have ones that only have a single letter. So for example, A and even B alone. You can also have others that have A, B as in 2 of length 2, only two symbols, right? You can also go even further and have one that have a language that have 3, right? So something like maybe an example A, or maybe something like A, B, right? So that is what I'm pointing towards. Right? So when I say here that I want us to come up with a language that only accepts a length of exactly 2, it means, right? So only 2 symbols. What possible combinations can you have of only 2 in length of A and B, right? A string that only has 2 symbols alone. So one of them you can have is AA, another one you can have is AB, another one you can have is BA, and the final one you can have is BB. Okay. Now how can you reduce this? So this is where you go back to a bit of algebra, some math. Okay? So this one, we said the way you are mentioning it, it's AA or AB or BA or BB. So that means you can also write this as AA plus AB plus BA plus BB. So how can we simplify this further? I hope we are together. How can we simplify this even further? What we can do is we can take out what is common. What is common for the first 2 and the last 2, right? So in this case, if I was to look at these 2, there's something that is common, and these 2, there's something that is common. Okay, so in this case, what is common here? It's A. So I can have just A, and then I can have A plus B. Okay, and then plus what is common here? It's B, and then I have A plus B. So I don't know whether you recall things like this that you did a while back, and people are always talking about. I don't see where I apply things. Math. I think this is high school math, if I'm not wrong. So this is similar to that. Okay, so in simple terms, okay, the regular expression that can describe a language that is of length 2 is this. Okay. Are we together up to there? I need to hear some acknowledgement somewhere. Oh, people are getting out of class. Is everything okay in terms of the network? If you're having network trouble, just let me know. because I know Zoom may have an issue, and then they'll say that you're not in class. So just inform me if you're having issues. There are people who I'm constantly seeing being kicked out of class and then back. Good. Let's go to the next one. I think that one was good. That was a good example. I think my space will be over for a while. Allow me to be very orderly today. To there, then down there. Then I can have a line here. Let me delete this. Perfect. So the second one then says a language that accepts a strings of length at least 2. How can you interpret that one? Someone write for me something there. How can you interpret that one? Okay, Kevin, that's okay. Yes, I think you're one of those people who has been having issues. It's okay. I hope you'll go through the recording later on. I'll upload it, and then you can just go through it. Okay, so yes, so I agree with what everyone is saying. So what we are saying is at least 2, and then anything more than that. Okay, so at least 2. The other one was exactly 2. This one at least 2. So that means this language, let's call it language 2. Okay, language 2 will have things like this. Within that language, you'll have words like this. You'll have a word like a. Okay, you'll also have another word like ab. At the same time, you'll also have another one like ba. You'll also have another word like bb. So similar to what we have before, but now you'll also have another word that's similar to a, right? Good. What Jaden has written there is very true. And then all the way to infinity, right? That way. Okay. So how can you represent this? Anybody? What do you think? So this one, the regular expression that is defined is, oh, by the way, this is the regular expression. This is r. This is r. Also, this is r that we are trying to reduce. This is r, right? So what you can describe it here, you can say this regular expression. Okay. You can see that up to this half, up to this part here. Okay. It's just this regular expression number 1. Okay. So you can also highlight it as regular expression number 1. Okay. And then, okay, and then, okay, let me remove the brackets. And then this one we can actually take just a plus b, and then just put it to the closure and explain why. So in essence, the regular expression that describes the second language is a plus b. There's a reason why it's not the plus. And then a plus b. And then finally, you will also take a plus b. And then the asterisk. Now look here. Okay. So we said we want a language that accepts at least a string of, that accepts strings of length at least 2. Okay. So if you want the ones that have at least 2, exactly 2, right? You'll just reduce this one to what? To 0, right? And you'll have nothing here, so that you'll only have 1. So that in this case, you'll only have a plus b multiplied by a plus b. So in that case, you'll have this one here. Okay. If you want one that is of length 3, okay, the asterisk, you'll change it now. Instead of having 0, you'll change it now to have 1. So that now it will be a plus b, okay, a plus b, then finally a plus b. So that one will give you of length 3. If you want for length 4, what do you do? Right? You see, you change this one to 2. That way, all the way to the end. Hope that is okay out there. All the way. Let me just draw a line here. Again, today I'm being very orderly. I even like the way it looks like. Good. So the last one. What do you understand by the last one? Anybody interpret for us? Language that accepts strings of length at most 2. Interpret. Good. I see someone saying 2 or less. Yes, the key word is 2 or less. Okay, 2 or less. So what does that mean? That means language number 3. Okay, will not only accept what we have here. Okay, this first one. It will also accept an empty string. So let me represent it with an epsilon. It will also accept a. It will also accept b, and now it will accept now this first one. So a It will also accept AB. It will also accept BA, and finally BB. Okay, let me put this one in curly brackets. That way. Perfect. So this can also be denoted as this, right? So the regular expression that describe this regular expression is epsilon plus A plus B plus AA plus AB plus BA and plus BB. Okay, so how many can simplify that one for me? By the way, in such an example, if you have to give me only this and not simplify, I think I'll give you the marks up to there because it seems good. But there is a way you can simplify. So how will you simplify that one further? Remember, it would appear in your formula somewhere. How will you simplify that? How do you simplify that? How do you simplify that one? Or even better yet, or I can give us as a challenge, and then I'll give the answer in the next one. I think that's better to give us time. Okay. Julie, there's something you're missing somewhere. So take note of that and simplify it for me. And then next time, if all of us come back with an answer, will give us points, all of us in the next class. All of us will get points in the next class. Okay. With that being said, let me just leave the whiteboard for a second and take you back to my notes. Okay. So as you can see, the notes that I have are the common ones that you'll find in literature and books, right? So you can imagine if you're trying to go through these notes and trying to understand how regular expressions are designed and how they come up, chances are you'll get confused, right? So that's the reason why I needed to deviate a bit. Again, the presumption in this case actually is you did regular expressions before. Okay, you did regular expressions before, but then I didn't want to have that presumption. Okay, so I just wanted everybody till the basics, at least the basics. Okay, so I'll try and find more questions on regular expressions and how you can come up with them. Then I'll post them on e-learning. Okay? But then in the next class, we are going to learn about this finite automaton, because okay, this is how you're going to now find the connection between our regular expressions and now how the tokenization is done. Okay? So that's what we are going to do next. I thought we'll cover this in one sitting, but then those are very many concepts. We need a breather after we've learned a new concept so that at least we can digest it. The next week we'll just talk about FA, and that I think will be enough for lexical analysis. With that being said, the time we are going to take it as a lab. I thought I'd give you like an hour. Unfortunately, time has not been on our side. I want you to go and look at what we talked about. I want you to go and look at Lex. Okay, let me go to the whiteboard. I want you to go and look at Lex. Just spend some time, even if it's 5 minutes. Go look what Lex is. Go look at what YACC is. And finally, go and look at what Lance is. Okay? And then we'll mark it as a lab. Moses has seen something. Moses Karanja has seen something. Not exactly. I like where you're headed. I like what you're thinking. Just a small tweak here and there, but you'll be there. Just look at it. Remember, again, I keep on reminding you, empty. There is this empty here. The empty string. How are you going to represent the empty string, Karanja? Think about it. So yeah, that's okay. For those who have spoken, don't worry. I recorded your ID, so I'll be able to give you a point. I saw the other day when I asked people to give me their IDs, everybody wrote it, so I wasn't able to know who it was. Now in this case, at least I learned my lesson. So the lab work is not something that you're going to submit. I repeat that, you're not going to submit, right? Something that you're going maybe to start submit maybe from next week. But I'm saying, because our class is supposed to be 3 hours, right? So I'm thinking we'll be learning for like 2 hours, and then 1 hour we can look at it as a lab when I can give you time to just go and look at something. Okay. So in this case, I'm just saying, just go and look at what Lex is, why ACC is, and LANs. If you're here during the first half of the class, you know what they were. If you're not, kindly check the recording, or maybe you can ask a colleague. But then even if you just feed this on Google, you'll be able to find some insights. Huh? Good. Yes, I see a hand. Can you be the only one who's going to ask a question? In case anyone else has, kindly just contact me via email so that at least I can give you some pointer. Yes. Yes, Julie.
Okay, I have a comment and a question. So
Okay.
my comment is, personally, I think Sheng is a regular language because
Okay.
it is formed through concatenation of other languages, and then
Okay.
my question is based on the answer that I've given.
Okay.
So I'm wondering,
Okay.
because in my answer I have an asterisk like outside,
Okay.
I was
Okay.
thinking the asterisk can mean
Okay.
we'll have an empty set. You can have an empty set. Is it
Oh, this one
right?
here.
Yeah.
Okay.
So is it right or wrong?
If I agree with it, everyone else would take it as the right answer. Okay. Let me do this. Let me say it's wrong. But then try and what we'll do is right. What we'll do is this, right? During the next time, the first thing that I'll do is just give the correct answer. Okay.
Okay.
Because if I say it's right or wrong, right, everybody else will relax and just go. Let me just say it's wrong. So let's us all go there. Because what I'm trying to emphasize is, right, remember in this case, there's this empty string here. That's what I'm emphasizing, because I see most people have covered the rest. Actually, even I think you've already covered the rest. But then this empty string, what happens to the empty string? Because I'm thinking, for an instance, where you know, when we talk about a language, you mean in some cases you need this word to say this word, even if it's empty. You need this word. In another case, you need to say this word called A. In another time, you need to say a word called B. Another time, you need another word called BB. I hope you're seeing that bigger picture. So that means you cannot ignore the empty.
Oh, okay.
Okay. Anyway, let me leave it open that way. I like when I leave people on a cliffhanger, because I'm very sure that the honest students are going to go and do some research, and then they'll get back to me. But then if you have more questions or more insights, like I said, don't hesitate to contact me via email. Okay, I'll always respond. The only time I don't respond on email is missed deadlines for submissions of CAT and assignments. That is the only time I don't respond. But other than that, I always respond and always give you points for that. So great. Today has been a very nice class. From the people who spoke. The rest who feel they want to get some points, contact me via email. Great. Have a great week. Go look at this, and let's meet next week, 9 sharp.